To factorize x squared minus 4x plus 4, first we need to add more terms by breaking down in a term with x power 1. In this case, that term is minus 4x. So to break it down, we have to find two factors or two terms which when we multiply x, they should give us 4x squared when we multiply them, and they should give us minus 4x when we add or subtract them. So for example, if we try minus 2x minus 2x, these two terms, when we multiply them, we get 4x squared, and when we add them, minus 4x, they give us minus 4x. So we can actually break down minus 4x in terms of these two terms, and by doing so we would have added more terms to our quadratic expression. So now we have x squared minus 2x plus 4. So it becomes easier for us to factorize our quadratic expression. So when we are factorizing, we take the common term out. For the first two terms, the common term is x, and we repeat the same procedure for the rest of the terms. For example, the common term here is minus 2. So and that's how we factorize our quadratic expression. So let's further simplify our expression. So we have x minus 2. So since these two terms are identical, we can express it as x minus 2 squared. Okay, so let's factorize x squared minus 4x plus 5. So we apply the same procedure as well. We want to break down 4x so that we can have more terms in our quadratic expression, and it will become easier for us to factorize it. So let's try 5x and 1x. So if we multiply 5x and 1x, we get 5x squared. But if we add 5x and 1x, we get 6x, which is not minus 4x. So we need 4x. So if we try minus 5x and 1x, we get minus 4x. But if we multiply these two, we get minus 5x, which is not what we need. So we are actually stuck, and there is no possible combination which we can use to break down 4x, or which we can use in terms to express minus 4x, which meets our requirements. So that's where the term completing the square comes in. Completing the square. So this proved to us that this quadratic expression is not complete, and this quadratic expression is also this quadratic expression is not a perfect square, because if it was a perfect square, it would have given us similar results to this quadratic expression. So if we also take a closer look to 5 and 4, we know that 4 is a perfect square, but 5 is not a perfect square. And if we rush to the result, if we complete the square of this quadratic expression, we will likely get the answer x minus 2 squared plus 1. Don't worry about how we got here. I will explain to you how we got it, how we got our final result. But for now, I want us to compare these two results. So the difference between these two results is, for this final result, we added a 1, and if you expand it, you likely get x squared minus 4x plus 5. Okay, so this shows us that when we are completing the square, we are likely to get an expression in form of this x minus h squared plus k. Okay, so this is what we call the vertex the vertex form. So this is the vertex form and this is the standard form. The standard form is ax squared plus bx plus c. This is the standard form. Also, this is an example of a standard form. So when you are completing the square, we move from the standard form to the vertex form. So, and when we complete the square of this quadratic equation, we are likely to get x minus 2 squared plus 1. So how did we get to this final result? Okay, so let's get started. To explain the method of completing the square, or how I arrived the final solution in the previous second equation, I will use this general quadratic equation to explain the process. Okay, so, and I'll also hold assumptions that a, which is the coefficient of a squared, is greater than 1, and also this quadratic expression is not perfect. So the first step is to make sure that a is 1, which is the coefficient of x squared. And if the coefficient is not 1, we have to divide it throughout all terms until the coefficient of x squared is 1. So let's make the coefficient of x squared 1. So we divide each term by a, until, so our result now is a x squared plus b over ax plus c over a is equal to 0. Okay, so that's the first step. Coefficient of x squared must be 1. Okay, so after the first stage, we move to the second, which is you identify the coefficient of x. We identify the coefficient of x, which is b over a, and then after identifying it, we need to divide the coefficient of x by 2. So after dividing it by 2, we have to square the result, and after squaring the result, then we have to factorize the square. Okay, so now we have completed the first step, which is here, so let's do the second step. So the second step, we have the third step, we did the first step here. This is the second step where we have to identify, and the third step we have to divide the coefficient of x by 2. So now it's b over a, let me use blue, b over a, we divide it by 2, right? So it's the same as b over a times 1 over 2, because when you're applying, we have to flip it, so it's now b over 2a. Okay, after obtaining b over 2a, now we have to square b over 2a by 2, which is the fourth step, right? Sorry, let me use the same, which is the fourth step, and now we have b squared over 4a squared. Or I'll explain to you why these steps are important. So now let's move to the fourth step. We need to factorize the square. So before we start factorizing this square, we need to introduce these terms which we have worked out into our equation. And we should also take note that when we are adding new terms to our equation, we have to make sure that our equation remains balanced, which means when we add something, we have to subtract something of same quantity, so that our equation remains balanced. Okay, So our equation a x squared plus b over a x, we add the new term b squared over 4a squared, and we also subtract this term because our equation has to remain balanced, and we add c over a is equal to 0. Okay, so let me point out that the part which you are more interested in is, let me use a different pen. Okay, this is the part which we have more interest in because it gives us the perfect square. We are not concerned much more with c over a because, as we have seen, as I said earlier, based on the assumption this quadratic expression is not perfect, which means c over a, which is a constant, is not helping in factorizing our quadratic equation. So we are not concerned about it that much. So this part is which we have more interest in. So okay, let me now explain these steps. So we use these steps to find terms which we can add into the equation, and also find terms or factors which we need to break down, like for example, when we do normal factorization, for example, let's say this, for this expression here in green brackets, when we do normal factorization, we will need to find okay, let me just, when we do normal factorization, we will need to find terms or factors. When we multiply those terms and factors, they should give us b squared over a x squared, b squared over 4a squared x squared, right? And those same factors, they should also give us b over a x when we add or subtract them, right? And we go through try and error until we get those two terms. But with completing the square, we don't have to stress much about that, because like this, the third and the fourth step, they make things easier for us. Okay, because okay, let me use a different pen. Let me use blue. When we divide by 2 here, we got b over 2a, right? And we got the result which we got, it gives us this product, and this product is also the same as this one, because like b squared over 4a squared is the same as this product. Okay, so which means b over 2a, it meets our condition, because if you add b over 2a and b over 2a, they give you b over a, because we simply divided here. They give you b over a. Okay, b over a, which is this term with the coefficient of x, and if you multiply b over 2a and b over 2a, they give you b squared over 4a squared, which is this step here. So this step, they help us to find those terms, to break down our quadratic expression, and also to find the term which we should add to our quadratic expression to make it easier for us to factorize that quadratic expression. Okay, so this is the most important part when you are completing the square, is to be able to identify that coefficient of x, and after identifying it, you divide it by 2, and after dividing by 2, you square it, and then you add it to the equation. And make sure you have to balance the equation as well. That's why I had to subtract it with b squared over 4a squared, because this is an equation, it should remain balanced. Okay, so it makes it easier for us to factorize our equation, so we don't have to search for any terms. Now we already have got the term b over 2a, so that term is b, let me use it's b over 2a x, and b over 2ax, because if we add these two terms we get b over a, and if we multiply b over 2ax and b over 2ax we get 4b squared over 4a squared x squared. Okay, so those is because of these steps that we are able to find these two terms first, and also the to find the constant which we should add to our equation. So now let's break down the coefficient of x, or b over ax. Let's break it down so that we have more terms inside our equation, and it makes it easier for us to factorize this perfect expression. So now if you break it down, we have now b over 2ax plus b over 2ax plus b squared over 4a squared in brackets, or I can say plus c over a minus b squared over 4a squared is equal to 0. Okay, now we simply factorize just like any other quadratic expression. We find the common term x and we factorize. We factor it outside the brackets. Let me use bigger brackets. And we also do the same for the rest of the two terms. We factor out b over 2a, which is common, and to prove that your answer is correct, you have to simply expand it. For example, b over 2a times b over 2a, it gives you b squared over 4a squared. And here we can also further simplify this term as a single fraction, but you can even leave it as it is, because there's no worry. We don't have to worry much about it. So let's further simplify. Let's further simplify our perfect square. So now we have x plus b over 2a, x plus b over 2a, and c over a minus b squared over 4a squared is equal to 0. Since these two terms are the same, we can actually express it as x plus b over 2a squared plus c over a minus b squared over 4a squared equal to 0. Okay, so now we have actually completed the square. This part is a perfect square. Or let me just enclose it in a rectangle. Okay, so this is now the vertex form. This is the vertex form. This is the vertex form. Or we can further rearrange. We can also rearrange it. Let me just rearrange it as, let's just multiply everything by a, everything by a, everything by a, everything by a, so that we need to make a comparison between the standard form and the vertex form. Okay, now we have a in brackets x plus b over 2a squared plus c minus b squared over 4a is equal to 0. Okay, let me also enclose this one in red as well. Okay, this is in vertex form. Okay, so let's take as I said earlier, I showed you an example of vertex form where I said when we are moving from vertex form, we are moving from standard quadratic form plus c, and we move to, when we complete the square, we should get something like this, right? when we move from standard to vertex form. So now let's compare vertex form to vertex form. So we see that A is equal to A is equal to A, X is equal to X because X is equal to X, and our H, which is here, it's negative. I can even say negative H, or is equal to B over 2A, or I can say H is equal to minus B over 2A. Is still the same thing. Okay, now we are left with K. Let me just write it here, and K is C minus B squared over 4A. That's our K. Okay, so I have further simplified I made our comparison between the vertex form and the standard form. So let's just assume A is equal to 1. Okay, so here our assumption was that A is greater than 1. What if A is 1? So if A was 1, then which means we are mostly, if A is 1, which means our quadratic expression, our standard quadratic expression will be this form when A is 1. Okay, and on that case, when A is 1, which means even our vertex form would also change. It will be X minus H squared plus K. Okay, because A is 1. Okay, which means on that case, let me just write it. If we convert when A is 1, let me say when A is 1. When A is 1, our vertex form will be this. This will be our vertex form. Let me just use green pen. In bracket, X plus B over 2 squared plus C minus B squared over 4 is equal to 0. Or let me just enclose it in a rectangular red ink. You see, this will be our result, and certainly we can even make a comparison. Of course, X is X, and okay, let me just make the comparison here on this side. Of course, X is X, and A, of course, A is 1. We are making a comparison, we can use this part, or we can use this vector. It's still the same thing. There's not much difference, but we see that our H now is negative B over 2, and our K, let me move it a bit, and our K, it's C minus B squared over 4, and this is our H, and this is our C. So which means if you are given a certain equation in this form, and you can quickly even convert it to this form using these formulas which I've just written here. And I will do examples on how to do this, which means if you want to find K here, the value of K, you just have to substitute C minus B squared over 4. We'll do those examples, but now let's apply this process which we went through here to finally complete the square for x squared minus 4x plus 5. So to complete the square, we don't have to go through the process of finding factors. Okay. let me just move it a bit to the left. So first we have to make sure that the coefficient of x squared is 1. Here it's already 1, and since that's cleared, let's move on to the next step, which is to make sure that we identify the coefficient of x. Identify the coefficient of x, which is -4, and we divide it by 2, which is -2. And after dividing by 2, we have to square the result. We get 4, right? And now we have all what we need. Okay, so as I said earlier, the main part which we have more interest is this part, because as we have seen earlier, this constant 5 is not helping us that much. It's not helping us that much, which means that's why by saying completing the square, we have to add terms which help us to factorize. And now let's add 4, because 4 helps us to come up with the complete square. So when we add 4, let me use another ink. So it's now x squared minus 4x. We add 4. We subtract 4, then we add 5. And as I said, this is the part which we have more interest in. And if we take a closer look to this expression and this expression, they are actually the same, because we have actually managed to find the term. We have actually managed to complete the square, because by this method we actually managed to complete the square, because this one expression is a perfect square. We have seen it, and that's why I said earlier that this 5 is not giving us much help in completing the square. Okay, I hope now it makes sense. Okay, so let's further factorize. Now we don't have to stretch by finding factors during the try and error. We already got them from this stage. We already got -2 here. Oh, sorry for that noise. Here, as you've seen, we had -2x and -2x. Here we have already got those two factors, which is -2. So there's no need for us to stretch finding factors. It's now easier for us to get those factors by completing by the steps which we went through earlier. So it's now -2x and -2x. We just simply expressed -4x in terms of -2x, -2x. We just broke down our expression so that it becomes easier for us to have more terms without affecting our equation. So we have +4 + 1, since -4 + 5 is 1, and this is the place of interest. So now it's now let's factorize common terms out. Now we have x -2, we have -2, and x -2 + 1. And if you need to make sure that you factorize correctly, you just have to expand -2x. It gives you -2x. -2 times -2, you get 4. Okay, and now let's further factorize our expression. +1. Okay, so since these expressions in brackets are the same, we can actually square them. So that's how we arrive to the final solution from standard form to vertex form. So the important step is this step where you identify the coefficient of x, you divide it, you square it, and when you add it, you have to make sure you introduce, you balance the expression. When you add the constant, you also have to subtract it, and then you have to break down the expression which has x, and after breaking it down, you simply factorize it. That's the whole process. Okay, let's do more examples.
The expression x squared plus 6x minus 12 can be written in the form p all in bracket x minus p squared plus r for all values of x. Find the value of p, q, and r. So to solve this problem, we can complete the square and compare the values to determine the value of p, q, and r. So we are not going to do the long method of completing the square right now, but we will use a different approach. So the way we will solve this problem is I have written some quick formulas to do that on this right side of the board. So if you are confused how we got these formulas, I'll just do a quick review on how I got them. Okay, I don't know if you still recall this part of the board where I was converting, where I was explaining the concept of completing the square from the standard form to this vertex form, and where I was converting from the standard form to the vertex form of this kind. So when I complete the square for this form to this vertex form, then I had to compare these two vertex forms. So when I compare that a and a are the same, x and x are the same, and that this h is the same as minus b over 2a, and the k is the same as c minus b squared over 4a. And I also compared with the vertex form when a is 1, where I also made this comparison where a is 1 and x is x, and h here was b over 2a, and c was, and k, which is k, which is this part, was c minus b squared over 4. So these are the formulas which I'll be using to quickly find the values of h and k, so that I don't have to do like the long procedure, because I know like the values to get h and k quickly from this form to this form. So those are the formulas which I'll be using for the problem. So let's solve the problem. So since we need to find we need to find p, q, and r, so we can start with p. So we need to know that p like is sort of the coefficient on x squared. So because if we expand this this vertex form to the standard form, the x squared will multiply with p. So generally the coefficient of x squared will always be the same with the coefficient of x squared in this form. And so we already know that of course p is the same as 1. We already know it, because like if we expand, like let's say we've expanded like times r, right? Let me just reduce. If we expand this, we get x like x minus q x minus q minus this minus plus r, plus r. So if we expand this form, we get x squared minus qx plus q squared plus r. So if we expand, we get px squared minus qpx. Of course, this and this will be 2 plus q squared plus r. So if we expand this expression to the standard form, it should be the same as x squared plus 6x minus 2. It should be the same. So which means if we are solving this problem, we can also say x squared, it should be the same as px squared. So from this we already know that of course p is equal to 1, because if we divide everything by x, we get 1 here, and we also get 1, so p is the same as 1. So with this problem, I didn't want to solve this problem like this, but I wanted to use these formulas to solve the problem. So of course we can proceed to solve the problem with this trick, but for now let's use completing the square. Let's use these formulas. So to find the values, of course we have already got p. I wanted to prove my point of why p is 1, and now we need to find the value of q and r. So q here, basing on these formulas. Also, one thing to note is this is when a is greater than 1, this is when a is 1. So this formula is sort of a repeat. This formula is sort of a repeat of this formula, of these formulas, because like here a is 1, because when a is 1, our h is minus b over 2. When a is 1, our k is c minus b squared over 4. Okay, but if a is greater than 1, then we use this formula. So since we need to find the value of q now, so q will be q, which is the same as q, which is the same as h, you see, or this h, which is this h, or this h is the same as h, which is minus b over 2a. But since our a is 1, so our a is the same as q, as p, sorry, which is 1. Since our a is 1, we have b over 2a, b over 2. That's why we are using this formula, which is minus, now we need to find the value of b. So b is b, we see like this is the standard form, and in the standard form this is our b, which is 6. Okay, and c, we see c here. So c in the standard form, it's minus 2. Okay, so we have minus 6 over 3, which gives us minus 2, and we have now we need to find r. So to find r is the same as k. R is the same as k. Is the same as k, where k is actually c minus b squared over 4a, or 4, because like we know that's our a is 1. Oh, sorry, our a is 1, so it will be equal to c. Here is our c minus 2 minus our b is 6 squared over 4. B is 6, so it's 6 squared over 4. So now we have r to be minus 2 minus 36 over 4, which is minus 2 minus 9, I think it's minus 9, which is minus 11. So yeah, we already got our r. This is our r, and this is our q, and this is our p. Okay, so we are just simply using these formulas to solve this problem. So we could also have made these comparisons completed. We could have used this formula to solve our problem further on. For example, okay, let's just compare our results with this formula as well. If I had proceeded, let's say we already find P, right? We already find P. Let me just copy this. Okay, where is the part? Okay, let me just okay, let's solve this problem using, and then we'll compare our results. Since we are comparing with the coefficients, for example, x squared and x squared, I mean like with terms of x. So we determine the value of p, and now we want to determine the value of q and r. I think this was plus r. This was plus r. Yeah, plus r. Okay. So now we have 6x is equal to minus 2 pqx. So we are comparing terms with x only, which is 6x and minus 2 pq. So of course the x cancels out. Now we have 6 is equal to minus 2 pq, and now we need the value of, we already have the value of p, so it's now 6 minus 2 p1 and q, and now we have minus 2q, and therefore q is equal to 6 over minus 2, which is minus 3, and we got q. Now we need the value of r. So for the value of r, we are dealing only with constant, which is minus 2 and this part. So just do it. So we have minus 2 is equal to q squared p plus r. Okay, so it's now minus 2 minus q squared p plus is equal to r, and so minus 2 minus q, which is minus 3 squared p, we have already have p, which is 1, is equal to r. So it's now minus 3 minus 9 is equal to r. So minus 11 is equal to r. Of course we have our p, our q, and our r, and I think our results are consistent. So yeah, there are many ways to solve this problem. You can either expand by expansion or comparing, but by using this method of expanding and comparing terms, coefficients, terms of x, comparing like terms with the same x, which have the same power, order of power. Okay, and okay, let's solve more problems. For all values of x, 3x squared minus 7x minus 6 is equal to 3 all bracket x minus p over 2 squared minus q. Find the value of p and the value of q. Okay, so we can either complete the square and find the values of p and q, or we can expand the right hand side of the equation. So let's just choose the new approach to solve this problem. So we'll also expand the right hand side and compare our results, like compare with the terms of x. So first let's expand let's remove the brackets by expanding. So now it's p over 2 x minus p over 2 minus q, and it becomes x squared minus p over 2x minus p over 2x plus p squared over 4 in bracket minus q, and which is 3x squared minus if we add minus p over 2x and minus p over 2x, we get px, we get negative px. So now we have p3, we multiply by 3px plus 3p squared over 4 minus q. So this is 3x squared minus 7x minus 6 is equal to, okay, I don't think I've made any mistake here. Okay, let's just assume I didn't make any mistake and continue. Okay, so now our next step is to group like terms together, of course. Okay, there's no need to repeat anything. So we will continue, we'll compare x squared and x squared, and we'll compare 7x with this part minus 3px. We'll compare also the constant minus 6 with the constant 3p squared over 4 minus q, and solve our problem. So now we have 3x squared is the same as 3x squared, so yeah, it's true, and minus 7x is the same as minus 3px. We cancel with minus x and minus x, and now we have 7 is equal to 3p, therefore p is 7 over 3. Okay, and now let's compare the constants. So let me use a different ink. So I have minus 6 is equal to 3p squared over 4 minus q, and we need to find the value of q. So it's minus 3 p squared over 4 is equal to minus q, and we already got our p. So first let's remove the negative 1. We factorize the negative 1 outside. Of course our negative 1, because these they will cancel out. Yeah, okay, and now we have q, which is the same as 6 plus 3p power 2 over 4, and our q is 6 plus 3 p, we find p to be 7 over 3, so we have 7 over 3 squared over 4. So we can further simplify, same as 349. This is okay. Let me just do everything here. Now it's 49 over 9, 3 all in brackets divided by 4, all in brackets, and this it's 3. So it's now 49 over 3 divided by 4, or times 1 over 4, which is 49 over 12. Okay, so we have plus 49 over 12. 49 over 12. Can we, of course we can further simplify our answer is 12. 12 into 12 is 1, so it's 49 plus 49 plus 12. 1 into 12, 12 times 6, 16, 6, 12, 6, 72. Yeah, I'm sure it's correct. 72 plus, so 72, 49, 9, 10, 11, 7, it's 11, 12. So Q is 121 over 12. I'm sure I didn't make any mistake. So yeah, this is our Q, and we already got our P. Of course, this is an interesting problem because we can also use completing the square to solve it fast, but we'll also try to complete the square to solve this problem fast if you can. Okay.
Use completing the square to solve the equation x squared plus 4x plus 5. So the first stage is to make sure the coefficient of x squared is 1. So here we see the coefficient of x squared is already 1, so there's no need to divide by anything. And the second stage is we need to identify the coefficient of x, which is 4. And when we have identified the coefficient of x, we divide it by 2, we get 2, and after getting 2 we square it by 2. Now we have 4. Okay, so now let's add new terms to our equation. So since this is an equation, I think let me just, since this is an equation, it should be equal to 0. Okay, so we have x squared plus 4x plus 4 minus 4 plus 5 is equal to 0. So this is a place of interest, this is a place of interest. So now let's further break down our problem. So now we need to break down 4x. So we have already got the term 2x plus 2x. 2x, it gives us 4x plus 4 minus plus 1, because 4x plus 5 is 1, is equal to 0. So now it's easier to factorize our equation. Now we have x, which is a common term between x squared and 2x, plus 2, then plus 2x plus 2 plus 1 is equal to 0. Now we can simplify our expression. Plus 1 equals to 0, x plus 2 squared plus 1 is equals to 0. So we have actually completed the square, but this question requires us to solve the equation, so which means we are not yet done. We need to find the value of x. So to find the value of x, we have to move 1 on to the right side of the equation, which is negative 1, and then we have to square 1. Then after squaring 1, we have plus or minus square root of 1, and what we did is we just times half, and half is simply the square root, which means, of course, this will be a complex number. The result is a complex number. So now we have x, we move 2 to the right side of the equation we have negative 2 plus or minus square root of minus 1, which is a complex number. As you already know, like the square root of 1 is the same as I for complex numbers. So we can further express as minus 2 plus or minus I, which is the value of x. Okay.
Solve by computing the equation 9 plus 3x minus 3x squared is equal to 0. First, we rearrange the equation 3x squared plus 3x plus 9 is equal to 0. Since 3 is a common factor, we can actually factorize our equation. So it becomes minus 3 and bracket a squared minus x minus 3 is equal to 0. And since our first intent is to have a coefficient of 1 on x squared, so now we have coefficient of 1 on x squared. We move to the next stage, which is to add more terms to our equation. And first we have to divide by 2, and when we divide minus 1 by 2 we get half, and after dividing by 2 we have to square our result. We get 1 over 4, and now we have to add new terms to our equation and also break down the term of x, the coefficient of x, so that we can have more terms to our equation. So let's add a new term, which is 1 over 4, and also subtract 1 over 4 because we have to keep our equation balanced. So this is our expression of interest. So when we are factorizing now, we don't have to try and error to get new terms, because we have already got the other term, which gives us minus 1 when we add or subtract it, and which gives us 1 over 4x squared when we apply the two factors. So we already know those two factors. It's minus 2x and minus 1 over 2x and minus 1 over 2x. If you add this, it should give you minus x, and if you multiply these two, you get 1 over 4. And we can also further simplify this into a single improper fraction. So our common denominator here is 4, and take note that this negative is for this expression, for this fraction. So we have 4 into 4, it's 1. 1 times minus 1, it's minus 1, and this is the same over 1. 1 into 4 is 4. 4 times minus 3, it's minus 12, is equal to 0. Let me also highlight, this is our place of interest. So since we have added new terms and also we have maintained our equation, it's now easier for us to factorize and come up with our perfect square. So the common term between the first two terms is x. Now we factorize it, and the common term for the rest of the term is half, and we also do the same, factor out half, and here we have 13 over 4 is equal to 0. Okay, so now we further express our term as in brackets so that it becomes easier to express it as a perfect square. So now we have our perfect square, which is x minus half squared, because these terms inside the brackets, they are the same, and we can also move this constant to the right side of the bracket. We have 13/4. Now, since our intent is to solve the equation and not only to complete the square, we should further remove the square. So the way we remove the square is we have to multiply by a power half. So this power half would actually cancel out 2, and on this side, and also this side, whatever we do on the right side of the equation, we do whatever we do on the left side of the equation, we do it on the right side of the equation. So now we arrive to this stage where we have plus or minus, and remember power half is the same as 13/4, and after arriving to this stage, we can express x as, when we move off to the other side, it's now 12 plus or minus square root of 13/4. It becomes positive, the half becomes positive. So now our final result is half plus root 13/2, or square root of 13/4 is the same as square root of 13 over square root of 4, which is square root of 13, square root of 13/2, or we have half minus root 13/2. So these are our two solutions.
For all values of x, x squared plus 6x minus 2 is equal to all in bracket x plus p squared plus q. So find the values of p and the value of q. So the value of p. Okay. So for this problem, we necessarily don't need to complete the square, although it's another approach which we can use, but we can simply expand this what's on the left side of the equation and equate based on x, like on the power of x. Okay, so this equal sign is just implying that what's on the left side of the equation is the same as what's on the right side of the equation. So the way we solve it is x squared plus 6x minus 2 is equal to x. Now is x plus p plus, we need to expand the brackets. Okay, so now expand the bracket. X times x is x squared plus px plus p squared plus q. Okay, so let's group like terms. So now we have 2px plus p squared plus q. Okay, so while we are here, so since we are making comparison between terms with the same with the same power of x, here x2 we compare with this term, and we compare this part with this part, and lastly we compare the constant. So p squared plus q is a constant, and minus 2 is also a constant. So now let's solve. Now, as we said, x squared is the same as x squared, and 6x is the same as 2px. So now we can solve for p. So which means the x's, they cancel out, and we are left with 6 is equal to 2p, and therefore p is equal to 6/2, which is 3. Okay, we found the value of p, now we need the value of q. So to find the value of q, now we are equating the constants. Okay, let me use a different ink. So -2 is equal to p squared plus q, and we have already got p. So now it's -2 is equal to p, which is 3 squared plus q. Okay, so now we've got our p. Okay, so yeah, so it's -2 minus in bracket 3 squared is equal to q. So our result is -2 minus 9 is equal to q, and which is -11 is equal to q, which is our final result. So our q is -11 and our p is 3. So yeah, we have already got our result, which means if we were to express this x squared plus 6x minus 2 in this expression, our answer will be x, then p we got I think p got 3, x plus 3 squared, then minus, is it -11? Yeah, q we got -11. Q equals -11. So this will be our Vertex form. So that's the final answer.
Use completing the square to solve the following equation: -2x squared minus 6x minus 1. Okay, so we will use the formulas instead of doing the rigorous method procedure. So we have let me use a different ink. We have -2x squared minus 6x minus 1. So first we use the same form as ax squared plus bx plus c, right? So which means our a is -2 and our b is -6 and our c is -1. Okay, so we are moving from here to here, right? So this already tells us that our a, we have already got our a here. This is our a, and we need to find h and k. H and k are the missing part. H and k. So to find h and k, we use these formulas. So let's solve. So our h is minus b over 2a, which is equal to minus, in bracket, -6 over 2a is -2, which is the same as 6 over -4, or 3 minus 3 over 2. Okay, and we need to find h. H is the same as c minus b squared over 4a, which is equal to -1 minus b squared. We already have b here, -6 squared over 4a, which is -2. So our k is -1 minus 36 over -8, which is the same as -1 plus 36 over 8. 36 over 8 So which is, I think it's the same as 36/8 minus 1 should be 3 and 1/2 or 3,5. Okay, so since we have found the values of h and k, so we are now converting. So which means a we have a2, then we have h, which is minus 3/2, and we have k, which is 3/5. Okay, so now we need okay, so now we have a in bracket x minus h squared plus k. It's now 2x minus, or because h is minus 3/2, so it's now minus in bracket minus 3/2 squared plus 3,5. So our intention is to solve this equation, so we are not yet done. So now let's solve the equation, which is the same as x plus 3/2 squared plus 3,5 is equal to 0. And let's now solve the equation. Squared, we move 3,5 the other side of the equation to the right side of the equation. You divide it by 2, and now we have x plus 3/2, and we also multiply everything by this one, cancels out by half, everything by half, power half, to cancel out the square. So now this one is now a square root. So now we have x plus 3/2 is now equal to plus or minus square root of 3,5/2, and which is the same as plus or minus square root of 7/2. Of course, square root of 3,5/2 is the same as 3/2. What did I got here? 3.5, which is the same as 7/2. 7/2. It's 7/2. Sorry, 7/2/2, which is square root of 7 over square root of 4. So that's where I got this one. And so x plus 3/2 is equal to plus or minus square root of 7/2, right? So x is now minus 3/2 plus or minus square root of 7/2. And I think I made a mistake somewhere. Yeah, I made a mistake. I left the negative. The negative. So we can further we know that from complex minus 1 is the same as I. So of course we have a complex plus or minus root 7 times root -1 all over 2, which is the same as minus 3 all over 2 plus or minus square root of 7 I square root of 7. Yeah, that's how we solve the problem. I think my answers are correct. You can check that for me if they are correct. But yeah, the procedure, what's important is the procedure of the method, if you understand the concept. Okay. So before we proceed to the next question, I just wanted to point out about the minimum and maximum points. So completing the square can help us to also to draw graphs. So for example, if you are dealing with a quadratic equation which is which you cannot factorize easily, you can complete its square and use its vertex point or vertex values to determine like where its maximum and minimum are. So it becomes easier for you to draw that graph. So when you complete when you change from the standard form to the vertex form, okay, so the minimum value or the maximum value of the parabolic equation is determined by h and k. So this is h and k. So h and k determine whether they don't determine if the graph is minimum or maximum. If the graph is a maximum or minimum, but they show where the maximum or minimum are. The coordinates, they give the coordinates or where the minimum point or the maximum point is. But when a, which is the coefficient of x squared, is greater than 0, then we have a U-shaped graph or a graph facing upward, and we have a minimum. But if a is less than 0, then we have a maximum value. We can determine the maximum value of the parabolic curve. Okay, we cannot determine the minimum value of this curve because we don't know where this graph can end. It might proceed on and on and on. We don't know because we are not even given the limits of this curve. So maybe it's just x for all real values. We don't know. But unless if we cannot determine its minimum value, because maybe it's h for all real values. The same for this graph where a, which is the coefficient of x squared, where it's greater than 0, we can basically determine its minimum value. Okay. So we have a problem here which says find the minimum point of the curve lx squared plus mx minus n. So we need to find the minimum point of this point. So as I said earlier, the vertex point, if we convert from standard form to vertex equation, so to vertex form, hk is actually the point or the coordinate of the minimum or maximum point, but the value of a is the one which determines whether the equation is maximum or minimum. So from this statement, we are just assuming that L is greater than 1, or it's positive because this question is asking us to find the minimum point of the curve. So this curve or this parabolic curve will be sort of this. It will be facing up from this statement. That's what we are assuming. It's just an assumption because these are just letters, they are not numbers. Okay, so the way we solve this problem is ax squared plus mx minus n. We have to complete the square. And the fastest way we can do it is by using these equations. Okay, so we know that lx squared plus mx is equals to n is, we can equate it with a squared plus bx plus c, right? We need to find the value of a, b, and c. Like those are the ones we use a, b, and c to find the value of k and h. So we already know that a is L, and we also know that P is M, and we know that C is minus n. So yeah, then we need to find the value of h. So h is minus b over 2a, so which is minus b, which is m, and a, which is l. So this is the value of h, and we now need to find the value of k, which is c minus b squared over 4a, which is c minus b squared over 4a, and our c is minus n minus, and our b is m squared over 4, and our a is a is l. Okay, so we find our m, and we simply have to simplify further if possible. We use minus m squared over 4l. We can actually simplify, it's possible, make it a single fraction, 4nl minus m squared, sorry, negative. Yeah, I think it's correct. So since, as I said, we have to express this, which is the same as what is our h, by the way? Our h is minus m over 2l, and our k is minus 4nl minus m squared over 4l. So these are the coordinates of I don't know the coordinates. So these are the two coordinates of the minimum point of the curve. So the curve will be facing upwards. So that's the way you solve it. So for this question, we need to find the vertex point on the curve x squared minus 6x plus 11. So the procedure is still the same. So it's x squared minus 6x plus 11. We just compare with ax squared plus bx plus c. So okay, let me use it. So you just compare coefficients of x with the same power, x squared. So this is 1, so which means our a is 1, and we compare minus 6x with bx, so which means our b is minus 6, and our c is 11. So yeah, we have our a, we have our a here, we have our b here, and we have our c here. Now just calculate h and k. So h is equal to minus b over 2a, which is minus what is b minus 6 over 2a1, and 6 over 2 is 3, and we also calculate the value of k. So the value of k is c minus b squared over 4a, which is 11 minus b squared over 4a, for which a is 1, right? So it's 11 minus 36 over 4, and which is 11 minus 9, which is 2, right? I think it's correct. So we have our h and k to be, so we have our h and k to be 2, sorry, it's 3, it's 3 2, it's 3 2. This is our h and k. So we can actually even draw this graph, and since we have the vertex point, we can actually try to draw the graph itself. Let's say, so we know like at point 3, 2, which is at point 3 and 2, they say it's here, this is the y-axis, this is the x-axis. So we don't know like where the graph casted the y-axis. So the graph is x squared minus 6x plus 11. So it's x squared plus 6x minus 11. Is it minus? Is it? Oh yeah, I just made okay. Minus 6x plus 11. So we need to just draw this graph. Of course, it's concave up, because the coefficient is greater than 1, greater than or equal to 1. So it's concave up. It will have a minimum value. So this is the minimum value of the parabolic curve. So if we will need to find the y intercept of this curve, which means x should be 0. So when x is 0, which means if x is 0 for this equation, we will actually determine the value of, so f of 0 is actually 0 minus 0 plus 11. So on 11, that's where we have our intercept. So yeah, that's the way this graph will look like, concave up. Okay, we have an interesting problem. By completing the square, sketch the graph of the following curve: 2x squared minus 4x plus 5. Okay, so we'll just use these formulas to quickly complete the square and sketch the graph. So it's 2x squared minus 4x plus 5. It says the same as x squared plus bx plus c. Of course, a is 2. We just take it in the coefficients of terms of x with the same power. So it's x squared and x squared. Now it's b of course it's minus 4, and c is 5. And now we need to find the value of h, which is minus b over 2a, which is minus 4 over 2a, which is 2, and we have 4 over 4, which is 1. And now we need the value of k, which is c minus b squared over 4a, which is c minus, c is 5 minus b squared, which is minus 4 squared over 4. What is a? A is 2. So it's 5 minus 16 over 8. So now k, it's 5 minus 2, which is 3. I hope I didn't make a mistake. Okay, let's just continue. HK is now 1, 3. That's HK. So now let's replace H and HK in this equation. So as you already saw that a x minus h plus k, of course, is with our a is what's a? 2. A is 2, x minus h is 1 squared, squared plus 3. Okay, now what we need is to catch the graph, is to sketch a graph. Okay, of course, the y-axis and the x-axis. So the vertex point is 1 and 3. Okay, 1 and 3, that's so 1, 3 here, because that's the vertex point. And from the looks of things, as long as a is greater than 0, it means that it will have a minimum. The vertex point is the minimum point. The vertex point is the minimum point. So this is the minimum point of the graph. So 1 and 3 is the minimum point of the graph, and we also need to find the intercept of the graph where x is 0. So when x is, okay, let me just write on the other side. When x is 0 on this, that's where we get them. So f of x0, since it's just the same thing, the standard and the vertex form is just the same equation. Okay, so it's now 2 minus 1 squared plus 3. So we have 2 plus 3, which is 5. So here at 5, that's where we have our intercept. So yeah, that's how you plot your graph. So we have another one. By completing the square, sketch the graph of the following curve: 7 minus 4x minus x squared. So yeah, we'll just use the same procedure. First we have to rearrange our equation. So we have minus x squared minus 4x plus 7, ax squared plus bx plus c. So of course minus 1 is a, and minus 4 is b, and 7 is c. And now we find the value of h, which is minus b over 2a, which is minus b, which is minus 4 over 2 minus 1. This will give us 4 over minus 2, which is minus 2. And so to calculate the value of k, k is equal to c minus b squared over 4a. So c is 7 minus b, which is minus 4 squared over 4, and the value of a is minus 1, which is 7. Okay, let me just scroll. Okay, oh sorry, so k is equal to 7. So of course plus minus and minus becomes plus 16 over 4, which is 7. 4 squared is 16, plus 4 into 16, I think it's 4, and goes to 11. So we have our k and our, so our hk is minus 2, 11. Yeah, minus 2, 11. So now what does this question requires us to sketch this graph. So of course a is less than 0, so this is the maximum point of the parabolic curve. So let's sketch the graph. We have the x, the y, and the x-axis, and we also need to find the, okay, let's first so it becomes, okay, I forgot that part. So it's a x minus h plus k. So now it's a was minus 1, which is x minus k, h, which is minus 2, which is now plus 2, squared plus k, which is 11. Okay, so we have h, which is 8. So this is the x coordinate and the y coordinate. X is 2 and y is 11. So how about the y? This is y, this is x, but we also need the intercepts, the y-intercept. So when x is 0, we need to find what is the y-intercept plus 11. So we have minus 2 plus 11, which is squared, minus 4 plus 11, which is 7. So it's 7. That's why we have the intercept. So this is the point where we have our minimum, and so our graph will look like this, and it looks like it is it is an x, it is an x, it is a 2x intercepts, or it cuts the x-axis at 2 points. So to find those 2 points, since we have already completed the square, we should solve for x. We got minus x plus minus x plus 2 squared plus 11. So we should solve for x. This is equal to y, right? But when y is 0, so it's equal to 0, so we should solve for x. Now we have x minus plus 2 squared is equal to minus 11, and now we have the negative cancel out, so we have x plus 2 squared is equal to 11, and x plus 2, so we remove the plus or minus, we remove the square here, so that we have plus or minus square root of 11. So now x is equal to minus 2 plus or minus square root of 11. So this gives us the two intercepts, or where the graph or the curve cuts the x-axis. We have 8 minus 2 minus root 11 and 8 minus 2 plus root 11. Yeah, of course, root 11, this one, the result will be positive and this result will be negative. Also, that's how you solve the problem. Okay, so we'll just do this one as our last problem. So express x squared plus 4x minus 5 in the form ax plus b squared all in bracket squared plus c. So we have x squared plus 4x minus 5. We want to express it in this form. Of course, we have already gone through various methods to solve this problem, but we will just use these formulas for the last time. So this is the same as x squared plus bx plus c. So we just compare and solve the problem. So our a is 1, our b is 4, and our c is minus 5. And of course our h is minus 4 over 2 times 1, which is minus 2, and our k is equal to c minus b squared over 4a, which is minus 5 minus b, which is 4 squared over 4a, minus 5 minus 16 over 4. So our final result is k is equal to minus 5 minus 4, which is minus 9. So we have hk to be minus 2 minus 9. So we need to express it in the form ax plus b squared plus c, and of course we have already got our h and k. Simply have to substitute in place. So a was 1, so it's x plus b. We of course b and c is the same thing, plus b, which is minus 2 squared, plus c, which is minus 9. Yeah. So to prove if your answer is correct, you can simply expand. So it's x squared minus 4x plus 4 minus 9, which is x squared minus 4x minus 5. Okay, we made a mistake somewhere. Plus 4x. Okay, yeah, we made a mistake here. It should be positive. It should be positive. Should be positive number. Should be a positive number. This mistake comes into play because we are used to this form ax minus h squared plus k. So, and if you want to express to x plus b squared plus k, it's actually a different thing, because in that case it's now x minus b squared in bracket plus k. So yeah, that's where the mistake is. So which means here from this h is actually minus b, or which means our h here it should be minus 2 sort of, which is 2 h. So here we should substitute 2, not minus 2. Okay.